Next up, we have oral presentation 6, Winfield, Alabama. They're presenting a Mission 13 flight experiment.
Hello, I am Savannah Williamson and we are from Winfield, Alabama. We also did the effects of microgravity on purifying water.
And I'm Luke Clark.
I'm Davis Holbrooks.
I'm Luke Jungles.
I'm Tanner Edmond. Alright, so our mission is very simple, but ever yet so important. We want to purify water. We want to find a viable way to purify water in the presence of zero gravity. This is important because as we are traveling interstellar in thousands of years maybe, we will not be able to bring enough water for a growing colony. So we devised an experiment to use iodine to see if water with possible alien bacteria could be filtered so we could use it in growing colonies, such as in Mars and possibly the Moon. While there are big machines that use iodine to filter the water, this is using iodine tablets, which are lighter, faster, and more abundant. Iodine is safe, cheap, and lightweight, making it perfect. Our mission will determine if the iodine purifies the water efficiently.
Iodine versus chlorine. During our initial planning stages, we discussed if using chlorine or iodine would have been more effective in purifying the water. And after researching the effectiveness of the two, chlorine proved ineffective at killing all the cryptosporidium and giardia, while iodine can prove it effective to kill cryptosporidium and giardia cysts. After that, we decided what should we use, tablet form of iodine or liquid form of iodine. But since the FME is so small, we chose to do tablet form because the inability to measure the liquid iodine. So after 3 trials of 0.5 milligrams, 1 milligram, and 2 milligrams, we chose to do 1 milligram of iodine in tablet form. So after a contact with John Butane from Potable Aqua, he recommended to us that we do the process of mounting to get the most iodine, because in most prescription, in medicine and in industry, a lot of the 80% in the tablet is filler or excipients, so the active ingredient is not but 10% of it. So we made 4 mounds and then took the center of that mound and made another mound so that most of the iodine can be delivered to the pond water.
Okay, so for the FME mini lab, we chose to do a 3-chamber. At first, we were going to do a 2-chamber just to unclamp it and mix it up, but after Skyping with Dr. Yoshida Crowder, she advised us to use a 3-chamber so we could see the difference when they both went in microgravity.
The design of our experiment is very simple. Both volume 1 and 2 will have 3.5 milliliters of water, and volume 3 will have 1 milligram of iodine. On the first day of arrival, the astronaut will unclamp and mix volumes 2 and 3 and shake it for 60 seconds to mix the iodine and the water. 2 days after arrival, the astronaut will return and shake it again to ensure that iodine has been mixed. At the time of this experiment is going on in space, we'll be conducting our own experiment here in our lab.
Our plan is to determine the effects of microgravity on the purification of water using iodine. We will be using a water sample from pond water at our own school for the experiment. We'll be comparing the results of our experiment on Earth with the results of the experiment on the ISS. To make sure there is no microorganisms left alive afterwards, we'll use a variety of different tools. These include aquavial test kits, microscope grid slides, and petri dishes. We understand that there are other methods of purifying water that are already used that are more efficient, and iodine is known to cause thyroid problems if consumed in larger amounts. We believe this could be used to purify water in smaller amounts under emergency situations. And if we hypothesize that despite being under the effects of microgravity, the iodine will purify the water. And if our hypothesis is correct, we could use this in the long term in other emergency situations where drinking water is desperately needed.
We would like to give a special thanks to Winfield City Schools. Our superintendent is Mr. Cook. We'd also like to thank Ms. Birmingham, Ms. Kerr, Professor Tim Estes, Dr. Keisha Crowder, Ms. Cunningham, and John Butane. Thank you.